How to find the extreme values of a given continuous function on a closed interval a comma b. Find the critical points of the function f in the open interval ab. Evaluate the function f at all critical points and at endpoints a and b. The largest value in step 2 is the maximum, and the smallest is the minimum of f in the closed interval ab. The conditions of continuity and closed interval are essential for a function to have extreme values. Find the maximum and minimum values of f of x equals to 2x cubed minus 21x squared plus 60x on the closed interval 1, 6. The given function f of x is a polynomial and is differentiable on open interval 1, 6. Therefore, the extreme values must occur at points where the first derivative is equal to 0. The first derivative of the given function is equal to 6x squared minus 42x plus 60, which can be written as 6 times x squared minus 7x plus 10. Setting this equal to 0, we obtain x squared minus 7x plus 10 equals to 0, which implies x minus 5 times x minus 2 is equal to 0, which implies x equals to 5 and x equals to 2. The critical points, therefore, are at x equals to 5 and x equals to 2. Now we evaluate f of x at the critical points x equals to 5 and x equals to 2, and at the endpoints 1 and 6. F of 1 gives 2 minus 21 plus 60, which equals 41. F of 2 is 2 times 8 minus 21 times 4 plus 120, which equals 16 minus 84 plus 120 equals to 52. F of 5 is 2 times 5 cubed minus 21 times 5 squared plus 60 times 5, which gives 250 minus 525 plus 300, which equals 25. F of 6 is 2 times 6 cubed minus 21 times 6 squared plus 60 times 6, which gives 36. Now 52 is the largest value of the function at x equals to 2, and 25 is the smallest value of the function at x equals to 5. Therefore, the maximum value of the function is 52 at x equals to 2, and the minimum of the function is 25 at x equals to 5. Find the maximum and minimum values of the function f of x equals to x to the 2/3 times 20 minus x on the closed interval -1, 20. Taking the first derivative, f prime of x equals to 2/3 times x to the -1/3 times 20 minus x plus x to the 2/3 times the derivative of 20 minus x, which is negative 1, which is equal to 2/3 times x to the negative 1/3 times 20 minus x minus x to the 2/3. Taking x to the negative 1/3 as a common factor, we have x to the negative 1/3 times 2/3 times 20 minus x minus x. After simplifying, we have the following. F prime of x equals to 40 minus 5x divided by 3 times x to the 1/3. The critical points are at x equals to 0, where the first derivative fails, and at x equals to 8, where the first derivative is equal to 0. Evaluate the function f of x at the critical points x equals to 0 and x equals to 8, and also at the endpoints negative 1 and 20. F of negative 1 gives 21, f of 0 gives 0, f of 8 is equal to 8 to the 2/3 times 20 minus 8, which is 4 times 12, which equals to 48. And f of 20 is equal to 0. We have a minimum of 0 at x equals to 0 and x equals to 20, and a maximum of 48 at x equals to 8.